let's graph some compound inequalities. So generally speaking, there's only really two different connection words that come up with compound inequalities, or and and. And think of or as being one or the other. You get either one or the other, or mathematically possibly both. So one or the other, or possibly both. Whereas the word and means just both. So it would be an overlapping piece, essentially. So first example, so I have two examples here. One's an or and one's an and, so you can also see the difference between these. When we graph this or, we're going to do it, the final answer is going to be the black line down here at the bottom, but at least in the discussion, I'm going to use the blue line and the green line to better understand what I'm doing, so that way I can produce that final result at the bottom. Again, the bottom is the final result. This is the final down here would be the only thing that you would actually answer. But these two will help us along the way, and once you become a master of this, then you can start to sort of not do the first two stages, if you can think of them mentally. Okay, first, x less than 3. So that means we'd have to go to the number 3 on the number line. So I'm just going to go to an arbitrary place here and label it as 3. And we need to graph x being less than 3. So less than, at least in our convention with our textbook, is going to be an open dot. And less than that number means we would have to shade to the left. So we get a shading to the left from 3. On the other hand, the green inequality says begin at 5. So let's go to 5 right about there. And then this time the shading is going to be numbers that are bigger than or equal to 5. So that's going to be to the right. So notice that I'm actually tacitly using my skills from before. I actually forgot to label that point. We'll call that point 5. But the fact that the blue was a less than means it's an open dot. And then the fact that the green is a bigger than and equal to or equal to means it's a solid dot. So now when we bring them together into the final answer is going to require us to do all of the parts of the two graphs above that are shaded. So either shaded in one picture or in the other picture. So in the bottom graph, I'm going to label the 3, I'm going to label the 5, and at 3, I need to shade left from 3 because notice that the top line has this portion shaded. So we definitely have to shade left because the or means we shade either part, one that is shaded in the top graph or the bottom graph. We do not shade in between. The 3 and the 5 do not get shaded in between because that in between part was not shaded in either of the graphs. And then finally, down here we do have to shade 5, and we do need to shade to the right of 5 because the numbers from 5 and to the right were shaded in the bottom, the green graph. So the final solution is these kind of wings from 3 to the left and from 5 to the right. Now on the other hand, if we had a different graphing problem that was a conjunction, an and, then let's try graphing x less than 6 and x bigger than or equal to negative 3. So starting off in the same sort of approach here, go to 6, it's less than, so that's an open dot, and less than means shaded to the left. So the fact that it's not equal to is an open dot, sorry I should say, and then less than is to the left. For the green line, go to negative 3, it's equal to, bigger than or equal to, so that's going to yield the solid dot. And this one's bigger than, so that's going to be shading to the right. So when we come down to making the final graph, again the final solution's only this one at the bottom, it's going to go negative 3 and 6. And this time, since it's an and connector, we need the part that is shaded in both. So we don't include left of negative 3. That's not shaded in the bottom graph. We don't include to the right of 6. That's not included in the top graph, in the blue graph. The only part that we include is the region in between negative 3 and 6, because this region was shaded in both of the graphs. Negative 3 is in both graphs, solid dot. 6 is in only the bottom graph, not the top one, so we have to not include it, and that creates the open dot.